Hi everyone, this video shows another example how to solve problems pertaining to temperature change and the change of state. What you have here is 10 grams of ice at 0 degrees Celsius is added to 30 grams of water at 35 degrees Celsius in a calorimeter. You're also given that the final temperature of the mixture is 10 degrees Celsius. And you're asked to find the specific latent heat of fusion of ice. So first things first, you're given ice at 0 degrees, water and calorimeter at 35 degrees Celsius, and the final temperature is 10 degrees Celsius. So this is not stated explicitly, but it already implies that ice has to melt at 0 degrees Celsius before its temperature can start to increase. So with the information that you have deduced, take note, a specific latent heat of fusion is needed here. And actually when you read the question, you're required to find the specific latent heat of fusion of ice. Now, even though you have figured this out, that there's so-called a hidden data inside the question, don't attempt to solve it yet. You need to identify the temperature range or the point of where change of state occurs. So write out what you do know. 35 degrees Celsius versus 0 degrees Celsius. So temperature from 35 degrees Celsius is going to drop to 10 degrees Celsius. And when this happens, the temperature of water decreases, the temperature of calorimeter decreases. At 0 degrees Celsius, ice melts. And this is where change of state occurs. And this is where you have to find specific latent heat of fusion of ice. And then after it melts, the temperature has to increase to 10 degrees Celsius. That's why the final temperature of the mixture is 10 degrees Celsius. Again, as mentioned in the first few videos, please do not solve the problem yet. Lay out the data in a very structured way. It will take time, but it's worth the investment because you want to focus on solving the problem rather than figuring out what number goes into which part of the equation. And in the given space, divide the two parts, heat supply, heat gain, and fill in the necessary details. So for the heat supply, I have M1, C1 change in theta 1. This is actually the water. This is actually the water. And the M2, C2 change in theta 2. This is actually the calorimeter. Note that M2, C2 values are missing, but you are given heat capacity of calorimeter, which is 25.2 joules per Kelvin. And heat capacity is actually M2C2, which equals to 25.2. After that, identify the heat gain. And the heat gain is actually by the ice. And after the ice has melted, its temperature increases. So notice that I wrote melted ice instead of water because I need to differentiate with the water that is supplying the heat. So in case there's any confusion, as the ice melts, it gets mixed in the water, right? But one part of it is supplying heat, the other one is actually gaining heat. So we need to draw the two distinctions very clearly. And given the information, we realize that we don't need M2C2. Or should I say, we don't have to worry about M2C2 because we are given the heat capacity, which is C2. Hence, from here, we're going to use the principle of conservation of energy to form our equation. So you have heat supplied equals heat gain. Plug in the values, and I'm not going to show you how to solve it because I say again, this is a physics lesson, this is not a maths lesson, and hence I'm going to leave it as it is. Plug in the values, manipulate the equation, and you get L3 to be 336,000 joules or 3.36 times 10 power 5 joules. Both expressions are accepted, so you don't have to worry about this.